Hello everyone, my name is Seong-Soo Ryu, a graduate student at Aurora Research Group in University of Victoria. Today, I'm going to present about adaptive electronic vehicle charge system on demand. Here's the today contents. First, I will point some information about EV and the reason why the adaptive EV charge system has been proposed. Next, I'm going to explain the proposed system and scheme briefly. After that, I will show the simulation result and make these conclusions. EV has got a spotlight for next generation transportation for being more environment friendly than the conventional one. So these days, dissemination of EV has increased dynamically, and it is expected that the related industry field would grow tremendously as well. However, many countries have faced electricity shortage problems, especially summer. To deal with that, for instance, in South Korea, there's a different electricity fee policy depending on the time and seasons, like spring, fall, and summer and winter. Now, the world has started to restrict the use of electricity. However, the problem is that conventional EV charge system is not capable for those restrictions because it uses uniformly distribution charge scheme with full capacity, which means in peak time when the electricity fee is the highest, it still provides full charge speed with highest price. There are two types of conventional charge system. One is slow charge system, and which provide a charge speed up to 7 kilowatts per charge port and no communication between a charger and EV. The other is quick charge system. It provides the charge speed up to 50 to 150 kilowatts per charge port, and it provides communication between a charger and EV, such as battery status and state of charge. So additive EV charge system on demand has been proposed. Basically, it provides different charge speed depending on real-time charge demand and the total electricity capacity from the grid. As is to be figure, illustrate the concept. The final goal is to provide efficient charge performance, less charging time with less fee. Adaptive EV charge system consists of three parts: EV charge power switchboard system, control system, and scheduling system. EV charge power switchboard system is practically distribute the charge power based on the proposed additive charge scheme. The control system is the main operation and DV server. It controls the charge system remotely and collects the EV charge data. And it conveys the adaptive EV charge schedule from the scheduling system. The scheduling system is calculating the adaptive EV charge schedule by using the predicted charge demand. EV charge power switchboard system calculates real-time charge distribution by using the schedule. Like there are two types of EV charge types, slow and quick. The adaptive EV charge scheme is designed for slow and quick respectively. The design scheme has two procedure steps, scheduling and real-time distribution. Adaptive slow EV charge scheme is designed for business building field. So the EV slow charge scheme scheduling part is based on queuing theory. It uses the predicted charge demand, which contains the number of EVs and the amount of charge power each EV in unit time. From the queen theory-based algorithm, it calculates the EV charge schedule, basic policy. It provides least charge time, but most expensive charge fee. And it is impossible to get the EV's battery information, so this policy only provides the adaptive charge power per unit time, each port to charge EV fully. For example, if there are three charge ports and the policies decide to 3 ports at the specific time, the switchboard system distributes the power to the 3 ports as maximum, and the other, the less of port force, the system distributes the power uniformly, the rest of the power. So the predictive demand is very important. Luckily, the business building charge demand is quite stable. So yeah. And then for compensating the most expensive charge fee from the basic policy, the real-time charge algorithm here calculate the new charge power distribution simultaneously by using real-time charge demand and the peak time table, which is the different charge fee depending on the time. Yeah, so that makes the less charge time and less charge fee. Additive quick EV charge scheme is designed for EV bus garage field. The quick charge EV scheme scheduling part is based on mixed integer linear programming. It also uses the predicted charge demand, but it contains the bus delay and state of charge, each scheduled bus journey. From this algorithm, it provides the EV charge schedule, basic policy, least charge time, but most expensive charge fee. However, unlike slow EV charge, it is possible to get the EV's battery information. This policy can provide the least amount of state of charge SOC for the bus journey, which means it can reduce the bus departure delay. So this policy can provide the charge distribution according to the remained SOC on each bus journey routine. Like for compensating the most expensive charge fee from the base policy, the real-time charge algorithm calculates the new charge power distributions simultaneously by using real-time charge demand, like real-time bus delay and the bus's SOC, and peak time, and same as with slow charge, the peak time table. So the real charge, so like slow EV charge scheme, the real-time charge algorithm provides less charge time and less expensive charge fee. To simulate and verify the proposed scheme, the data from 2 test fields was collected as FIFO, first input, first output charge scheme, to get the maximum charge demand. Based on this data, the first, generate the random date and predict the charge demand except the generate data. Then calculate the basic charge schedule. With this basic charge schedule and the real charge demand of randomly generate date, simulate the proposed scheme and simulate the proposed scheme and uniformly the conventional scheme that uniformly distribution. And here's the conditions for simulating the proposed EV flowchart scheme. The data was collected from November 2018 to November 2019, almost 1 year. The point is the criteria for evaluating the performance. As you can see, there's no less charge time. Instead, there's a EV waiting time to start charging, which means it refers the less charge time. And here's the result. The left figure indicates the EV waiting time to start charging per hour. And the right figure indicates the charge fee per hour. As you can see, the waiting time around the noon here decreased remarkably, but the part of charge fee increased here. Increased while the charge fee after rush hour here decreased mostly. In the table, the proposed scheme provides more efficient performance than the conventional one, which means here is the total charge capacity is almost same, and the charge fee per 1 kilowatt is decreased. And the next is adaptive EV quick charge scheme. The data for quick EV charge scheme was collected from July to November 2019, almost 5 months. The conditions for simulating the proposed EV quick charge scheme are almost same as the slowest one. And just like the slow charge scheme, EV bus departure delays here refers to less charge time criteria. And here's the result. Left figure indicates the bus departure delayed time per hour. The right figure indicates the charge fee per hour. As you can see, the departure delay time decreased remarkably. Look here. But the part of charge fee increased while the charge fee usually decreased. Instead, the proposed scheme charge more after night here, because there's no bus journey. So in the daytime they charge the least SOC for bus journey, and then after the bus operation, after the bus routine, and then they charge the rest of the battery. As you can see in the table, the proposed scheme provides more efficient performance than the conventional one. Here and here. As a result, the proposed scheme provides better performance than that of conventional scheme by simulation. Actually, it's too bad there was no chance to apply the proposed scheme to the real test field. Usually, it is hard to get the field test with full accessing data we need. However, it is expected that when more EV information could be used, the proposed scheme will provide more efficient performance. Thank you. Does anyone have a question?
Yeah, I have a question. So in my understanding, the electrical grid can choose to give more power or give less power to one area. So if the grid choose to give less power to one area, and actually there are more like vehicles in that area need to be charged, and so the fee would be more expensive. Is that right?
Oh, sorry, I don't get it. Can you repeat that?
Oh, okay. So the grid can choose to give less power to one area because it predicts that there will not be too much vehicles there. So if actually it has a lot of vehicle and a lot of need a lot of power to so the fee will be expensive due to the misprediction. Is that right?
Yes, you're right. Yeah.
Oh, okay. Thank you. That's my question.
I have one question with regard to audio quality. I think maybe there's something wrong on my end, but I'm getting like a fair amount of static and distortion when people are talking. But it happens for both you, Young-Soo, and you. So I think maybe it might be a problem with my headphones that I'm using.
I don't know. I also have this problem. So.
Oh, okay. You're getting that too. Okay.
Oh,
basically, I'm getting a lot of distortion when anyone talks for some reason.
I think that's an internet problem. I don't know.
Okay, so everyone's experiencing this then? So there's some distortion from people's microphones when they're talking? Okay, well, maybe you'll be able to see what I'm about with the recording. I don't know whether the recording is going to have this distortion as well, but we will see anyway. It sometimes made it a little bit more difficult for me to understand what you were saying, Young-Soo, when you're presenting, but this is not your fault. It seems like maybe it's a Zoom problem. I could understand, but my hearing's not the greatest, and sometimes the distortion made it a little bit more difficult to understand what you were saying. Anyway, that's not your fault in any way. I have like a couple of kind of very basic questions. Like in Korea, I guess it sounds like in Korea the adoption of electronic vehicles is much more like widespread compared to Canada. Is that a fair statement to make? I'm not really sure how much EVs are used in different countries compared to Canada. Like, is there a lot more EVs sort of per capita in Korea compared to Canada?
Yeah, I think yes, but the problem is here it has a Tesla charger here, like Big Mart, but in Korea there's no Tesla charger, so many electricity company try to make their own electricity EV charge station. So yeah, the infrastructure in Korea is still growing about the charge station. Yeah, so that's why this project started.
Okay, and also just out of curiosity, who are the really popular like EV makers in Korea? Is Tesla popular there, or is it maybe like some of the Korean auto manufacturers? What manufacturers are the most popular there?
Usually the Tesla is the most popular, and maybe Kia and Hyundai, and also produce the like EV cars. So yeah.
Okay, so Tesla is popular even in Korea then. Okay, I wasn't sure. Right. It was only in maybe North America where it's more popular. That was all the questions that I had. I guess if there's no other questions, then I can stop the recording. So just 1 second.